Welcome to our last lesson in Unit 2. Today we're going to be looking at two variable inequalities and how to graph them. A linear inequality is an inequality that has two variables, usually x and y. Is a region of the coordinate plane that is bounded by a line. And that boundary line is going to be a graph line that divides the shaded from the non-shaded region. So it could look something like this, or it could look like this. And we'll talk about when we see each case and when is it going to be solid, when is it going to be dotted. Sometimes it'll be shaded below, we'll see it shaded above. And we're just going to practice how to do this together. So, graph the inequality. So our first step is going to be to find the slope and y-intercept since it's already in y equals mx plus b. My slope is 3. My y-intercept, or my b value, is -4. So I'm going to go to my y-intercept for -4. Oops, sorry. And then I'm going to do a slope of 3. I'm going to go up 3 and over 1, up 3 and over 1. I could, again, also go down 3 and back 1. Now, to determine if my line is going to be solid or dotted, I have to look at the inequality sign. If the inequality sign looks like this or this, in other words, if it has the equal to sign underneath it, it's a solid line. And if it's greater than or less than without that line, it's going to be dotted. So since this one has a line underneath it, it's going to be a solid line. And with these, I do want you to try to extend it as far as you can. I know that wasn't perfect, but we're going to just do your best. When it comes time for shading, there are some people who try to come up with tricks for which side you should shade on, but I really don't like using any of those because just too many mistakes get made. The best way to do this, and the way that I will expect you to do this, is that we're going to pick a test point. This can be any point that is not on the line. If 0, 0 is available, I usually choose that one just because zeros are easy to work with. And so what I'm going to do is I'm going to test the point 0, 0. And I'm going to plug it into the inequality. And we get 0 greater than equal to 3 times 0 minus 4. Well, this would give me 0 minus 4, which is -4. And so I'm going to say, is this a true statement? Is 0 greater than -4? It is. And since this is a true statement, I'm going to shade the side of the line that contains that test point. Since 0, 0 is on this side, I'm going to shade this side. And that's it. You will be expected to pick a test point and to show your work for checking it. It doesn't require really that much work. All right, so this one is in standard form, so I'm going to find my x and y intercepts. So for the x-intercept, I'm going to plug in y equals 0, and for the y-intercept, I plug in x equals 0. I'm going to get here 4x equals 8, because remember, if I plug in 0 for y, those cancel out. So I'm just going to skip that step. And here I'm going to get 2y equals 8. This would give me x equals 2, and this would give me y equals 4. I'm going to graph those 2 points. Now remember, this is my x-intercept, so I'm putting a point on the x-axis at 2, and this is my y-intercept, so I'm putting a point on the y-axis at 4. Again, if it's in standard form, no slope needed. Now, I have to decide, am I going to have a dotted or solid line? Because there's no line underneath this, it's just a less than sign, it's going to be a dotted line. And the reason I don't want us to just go a little bit past the dots and then stop is because when we do the shading, I want to look at, like, does this shade above it? Like, where does the line end? So please extend your line when you're doing inequalities all the way to the edges of the graph. Put your arrows on the end, and then pick a test point. Again, 0, 0 does not go through the line, so I could use that as my point. And really I could use any point. I could use 0, -4, I could use 6, 5. It doesn't matter. I just like zeros, especially in standard form, because what's going to happen is they're both going to cancel out and we just get that 0 is less than 8. This is a true statement, so we're going to shade this side that contains 0, 0. If we'd gotten something that wasn't true, we would shade the side that does not contain that point. So let's try this with absolute values. When a is not equal to 1, we have to use the method that we learned in lesson 2.5, where we are finding the vertex using the formula. So if I look at this, I've got M, A, B, and C. So my vertex would be negative b over a, which is 0 over 4, or just 0, and then c. So my vertex is at 0, 1. Then I'm going to make a table of my x and y coordinates. 2 points to the left would be -1 and -2. 2 points to the right would be so I have y, and I'm just going to treat it as an equals because I'm trying to find the y coordinate. We get y equals 4 times -1 plus 1. That would give me -4, and the absolute value of -4 is +4 plus 1, which is 5. 4 times -2 is -8. Absolute value is +8, and plus 1 is 9. Absolute value of 4 times 1, which is 4, plus 1, which is 5. And then 4 times 2, which is 8, plus 1 is 9. So we get -1, 5, 1, 5, 2, 9, and that's going to go a little off my graph, and that's okay, and -2, 9. All right, so same rules apply. Deciding if it's a solid or dotted line. Since there's a line underneath our inequality, this is going to be graphed with a solid line. There we go. And then I still have to decide, do I shade? Where do I shade? So instead of thinking of a line and shading on this side or on this side, now we're going to think of it as, are we shading inside the V or are we shading outside? So I'm going to pick a point. Just to show you that it doesn't have to be 0, 0, I'm going to pick the point 2, -3, just for fun. I realize I might have a different definition of fun than you, though. So I'm going to pick the point 2, -3, and see if this works. -3 less than or equal to absolute value of 4 times 2 plus 1. This would give me 9. Is -3 less than or equal to 9? Yes. That means that 2, -3 is a solution, so instead of shading inside, I'm shading all this area outside. All right, one more. This absolute value function does not have a not equal to 1, it is equal to 1. So I can use my translation rules. I'm going to find my new vertex, and so thinking about the translation, this -3 would mean that we're moving to the right 3. And this +6 would mean that we're moving up 6. So my new vertex is at 3, 6. Graph that point. And then I'm going to treat this as my slope. It's not technically slope, but it's the best way to think of it, I think. So from my starting point, I'm going to go down 5 and over 3. Oops. And then down 5 and left 3. Because, oh, I want to do that one more time. 1, 2, 3, 4, 5, 1, 2, 3. 2, 3, 4, 5, 1, 2, 3. Because there's no line under it, it's going to be dotted. And then the last thing I've got to do is pick a test point. This time I think I'll pick the point, do the point 0, 0 again. Zero is greater than negative 5/3 times the absolute value of 0 minus 3 plus 6. So 0 minus 3 would give me negative 3, but the absolute value is positive 3. So I've got 0 is greater than negative 5/3 times 3 plus 6. The 3's cancel, and we'd get negative 5 plus 6, which is 1. Is 0 greater than 1? Nope. That's false. So that means that the point 0, 0 is not a solution. So instead of shading inside where 0, 0 is, I'm going to shade all this area outside of it to show that that's where the solution is. I could check my work by picking a point outside of the absolute value function and seeing if that works. It should work. So this has been an introduction to graphing